Hello, my peeps. This Algebra Nation video will cover workbook page 7 times 6, problem number 8, part B.
All right, let's look at part B. So part B, we've got another compound inequality, but this time it's not an or inequality. It's not saying x can be in either direction. It's saying that x is going to be between two values. Well, what are those values that x can be between? All we're doing is solving for x. Now, when you have a compound inequality like this, you want to think about it. You've got your inside and then your outsides. You're always going to work from your inside out. You're trying to get x by itself in the middle. So let's start in the middle. What do we see going on here? Well, first thing that pops out to me is that I have parentheses. And whenever I have parentheses, I want to get rid of. How do you get rid of them? Distributing. Remember, we distribute whatever's on the outside to each term inside the parentheses. So we're going to distribute our negative 3 to the x. Negative 3 times x is what? Negative 3x. Okay, now we're going to distribute the negative 3 to the positive 5. And negative times the positive is what? Negative 3 times 5? 15. Negative 3 times 5 gives us negative 15. All right, let's write out the rest of our compound inequality. We've got negative 4 is less than negative 3x minus 15, which is less than 3. All right, cool. Remember, the goal is to get x by itself. We're going to do the same rules that we always do. What's keeping that x from being by itself? Well, that term has a minus 15. Negative 15 is attached to that negative 3x. 15 is being subtracted from negative 3x. Well, if something's being subtracted from negative 3x, how do you get rid of it? We're going to do the opposite. We're going to add. Now, what's the rule that we always do? Whatever you do to one side, you have to do to the other. It's the same idea here. Whatever you do on the inside, you've got to do on the outside. You've got to do to both of your other sides. So not only am I adding 15 in the middle, I'm adding 15 to both my outsides. All right, let's see what that gives me. Well, the middle of these negative 15 and positive 15 cancel out. We have negative 3x. Okay, what happens over here? Negative 4 plus 15. So if we have negative 4 and we're adding 15, same thing as saying 15. Take away 4, what does that give us? Gives us 11. Okay, over here, what do we see? We have a positive 3 plus 15. Well, if I have 3 and I add 15 to it, 3 plus 15 gives me 18. All right, now what? Am I done? No, we still want to solve for x. Well, what is x? We know that negative 3 times x is between 11 and 18. But we don't want that. We want to know what numbers x is between. So, negative 3 is being multiplied by x. I'm going to divide by negative 3. Whatever I do to one side, got it? I've got to do to all my sides. All right, let's see what happens here. Negative 3 over negative 3, those cancel out and we get x. Ooh, you guys remember that rule that happened in part A? What happened when we divided by negative? We had to flip the direction of our inequality. Same thing happens here. We divide by negative 3. This is no longer less than, I'm flipping it to greater than. It's no longer less than, it's a greater than, I'm flipping it. So we divide by negative, we got to flip our inequality. Now 11 divided by negative 3, can that simplify? No. Let's keep that as negative 11 thirds. 18 divided by negative 3, are we going to get a negative or a positive? It's going to be a negative, right? A positive over a negative is going to give us a negative. What's 18 divided by 3? 6. So we end up with negative 6. So we're saying, all right, x is between negative 6 and negative 11 thirds. So x is less than negative 11 over 3, but x is greater than negative 6. I don't like to write a compound inequality like that. I always like to have it in the direction with all of my less than signs. Well, saying that x is greater, this right here, just read this. You're saying that negative 11 over 3 is greater than x. X is less than negative 11 over 3. Well, if x is less than negative 11 over 3, isn't that the same thing as writing this right here? Are these two things the same? Negative 11 over 3 is greater than x. X is less than negative 11 over 3. X is less than negative 11 over 3. It's the same thing. Right. You're just writing it from a different perspective. All right, what about right here? X is greater than negative 6. That's the same thing as saying negative 6 is less than x. Well, if negative 6 is less than x, look what we just did. It's the same compound inequality. It's the same solution. You're just writing it from your other perspective. You got your smallest number all the way to the left. Makes it much easier for graphing your compound inequality. So let's go ahead and do that. All right, so when
I thought you said let's go ahead and take a brain break. If you have moves like this on the EOC, you will definitely get a 399. Do that on the EOC, and you will definitely pass.
now we're going to be dealing with a bunch of negative numbers. So I'm going to start with 0. I'll put a positive 1 over there, just to have it. We have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and our numbers keep going out to the negatives. All right, so our first one's at negative 6. Can x actually be negative 6? No, x has to be bigger than negative 6, right? X has to be greater than negative 6. So, can't be it. We have an open circle. Now, what about negative 11 over 3? Now, 11 over 3, I'm going to put that in my calculator. I'm going to see what that value is actually equal to. 11, make it a negative, divided by 3, negative 3.666. Where on my number line is that going to be? Well, I've got my negative 3. Am I going to the left or the right? Negative 3.66 is moving to the left. Negative 3.66 is right here. Well, we're saying that x can be between negative 6 and negative 11 over 3. If x can be between those two values, where are we going to shade? Are we going to shade the other directions? Could x be 0? Is x between negative 11 thirds and negative 6? No. We're saying all our possible values of x are between these two values. We're going to connect our 2 points. So when we have a compound inequality, looks like this, we're going to be looking between 2 points for all the possible values x would be. When you have an or, we're looking in 2 different directions for our possible values of x. So we took that complicated compound inequality and just broke it down and got our solution. If you guys have any questions on that, you know what to do. You're going to post on the wall. I'll see you guys in the next video.